Good morning, everyone. Last week we discussed on metals, right? And non-metals also we discussed. I told non-metals can exist as solid, liquid, gas, plus non-metals, they don't conduct electricity, and non-metals found in all three physical states. And non-metals are mostly found in which part of the periodic table? Rightmost side, group 4, 5, 6, 7. So look at here, I think I have shared this periodic table with you all. So in this periodic table, first three groups, you get mostly metals. Group 1, the first three columns, first three groups, except hydrogen. And non-metals are found in the boundary between metals and non-metals. Is the boundary between metals and non-metals. So hydrogen is a non-metal. Other than hydrogen, all this in this side metals. Other than hydrogen, all this side metals. If you have got a printout of this, so in your write separate in your writing book, I have given this table in your tutor also. These are you get non-metals. Rightmost side non-metals. So this is the boundary between metals and non-metals, boron and silicon. These two are called metalloids. These two are called metalloids. And all the others are non-metals, including carbon, nitrogen, phosphorus, oxygen, sulfur, fluorine, chlorine, helium, neon, argon. So all these are non-metals. All these are non-metals. Therefore, non-metals are found right-hand side of the periodic table, and metals are found left side of the periodic table. So this lithium, beryllium, sodium, magnesium, aluminium, potassium, calcium, these are metals. If you only can take a screenshot. So these 20 elements we have to remember, students. So what are the elements can be classified into three groups? Number 1, metals. Number 1, metals. Number 2, metalloids. Number 2, metalloids. Number 3, non-metals. So the elements in the periodic table we can put into three groups. So all the metals are solid. All the metals are solid. All these are solid. The metals are solid. All are solid except mercury. This side you get solid ones. All are solid. But these non-metals, some are gases, some are solid. For example, helium, neon, argon, these are gases. Gas. Nitrogen gas. And all these are gases. All these are gases. And these ones are solid. Sulfur solid. Phosphorus solid. Other than that, all these are gases, and carbon is a solid. So except the ones that have mark S, all the others are gases here. All the others are gases. Therefore, non-metals can be gases or solid or even liquid. There's a liquid non-metal called bromine. Bromine. Right. Hydrogen also, gas, that is the lightest element. Capital H, hydrogen, that is the first element of the periodic table. That is the lightest gas, lightest element, and the first element of the periodic table. And that is the lightest atom. So this is what we discussed last week. And today we are going to discuss them a bit further. Example, we are going to discuss these non-metals bit in detail. Currently we have finished metals. Metals we have finished, we have done. Okay, metals we have done. Now we are doing non-metals. Non-metals. So see whether you have copied down last week. Non-metals are found right side of the periodic table. Have you written that? We can ask this under MCQs also. Metals are found leftmost side of the table. Leftmost side of the table. Non-metal rightmost side. And metalloids come in between. Metalloids come in between metals and non-metals. Right. Then I'll erase this, right? If you want to take a screenshot, you should know at least the first 20 elements, exactly which elements are metals, which elements are metalloids, and which elements are non-metals. So we are discussing now these three non-metals bit in detail. What? You should know carbon. Carbon you should know bit in detail, nitrogen, and sulfur. These three non-metals you should know bit in detail. Carbon, sulfur, and nitrogen we are going to discuss bit in detail. Okay. Especially carbon and carbon, sulfur, and nitrogen. These are the three non-metals we are going to discuss bit in detail. Okay. Then back to the previous other page, the tooth. Some non-metals can exist more than one form in the nature. Some non-metals can exist more than in one form. So those forms are called allotrophic forms. Allotrophic forms. What are allotrophic forms? Sorry. When the same element exists more than one form in the nature. When the same element exists in more than one form in the nature, we call them allotrophic forms. I'll tell one example. Now the element carbon can exist in different forms in the nature. And one more thing I should write down, what? Majority of the elements discovered so far are metals. And majority of the elements are solid. Those things you should know. You should know about the things about periodic table. What? Most of the elements are not in this table. I'm talking about the long form, the full form of the periodic table. Majority of the elements discovered so far, identified, are metals. Most of elements identified so far are metals. Are metals. Metals. And they are solid. And most of the elements are, and they are solid. Except mercury. They exist in solid form. That also you should know. Metals left side and non-metals right hand side. And most of the elements discovered so far are metals. And most of the elements are most of the elements exist as solid in the nature. Now, okay, I'll erase this. Let's see again. Allotropic forms. I told this carbon, sulfur, and oxygen, and phosphorus. Not all the elements. Some element exists in more than one form, not man-made forms, not synthetic or artificial one. Naturally exist in the same element. No other element combined also. Same element can exist in different forms in the nature. Those forms are called what? Allotrophic forms. Different forms of the same element. Okay, right here. Look at the now. Look at the screen. Shows allotropy. What can you write here? Different forms of the same element are called allotrophic forms. Different forms of the same element are called allotrophic forms. Can write in front of this first line, right? Different forms of the same element. Different forms of the same element. Different forms of the same element are called allotroph. You can write that. They can ask that in definition in the exam. Are called allotroph or allotrophic forms. Write the word allotroph. Allotroph. Right. Then let's see allotrophic forms of carbon. Carbon, what are the allotrophic forms? Graphite and diamond. There are two natural, graphite also made of only carbon. Diamond also made of only carbon. Diamond also made of only carbon. Right here. Graphite and diamond. They are allotrophic forms. Actually, they are crystalline forms. Crystalline forms. They have a nice structure. Crystalline forms. Crystalline allotrophic forms are there. Then sulfur, actually, this is the appearance of sulfur. You can arrow, this is what? Physical appearance of sulfur. Appearance of sulfur. Actually, sulfur is a brittle solid. Because it's a non-metal, it's not malleable and ductile. It's a brittle solid, yellow solid. So there are two crystalline allotrophic forms of sulfur, that is rhombic and monoclinic. These also are crystalline forms, crystalline allotrophic forms. They exist as crystals. And third one, the third element which shows allotrophy will be what? First one, carbon, sulfur. Third one is oxygen. You can put if you want 1, 2, 3. Because you have to remember these examples for the allotrophic forms of oxygen, sulfur, carbon. So number 1, carbon, number 2, sulfur, number 3, oxygen. So oxygen, there are two forms. Can you tell me which form we breathe? One is present in the ozone layer, the other one we breathe. Now you can tell me the formula of the two examples, for the allotrophic forms of oxygen. One form we breathe, the other form present in the ozone layer. Can you guess the formula? Yes, reply on chat. The oxygen, not man-made ones. We have not produced oxygen. Oxygen is available in the atmosphere, that is released by the plants. There's no man-made oxygen in the world. So you don't pay for oxygen because you breathe, you pay for drinking, you pay for eating, but you don't pay for breathing because oxygen freely available in the atmosphere. So what are the two forms of oxygen in the nature? What are the two forms of oxygen in the nature? Yes. Answer is O2, and what is the other form? Yes, Rehab. What is the other form? No, not the physical state. Not the physical state. Not solid, liquid, gas. Now, what also can be ice, liquid water, and water vapor. They are not allotrophic forms. Huh? Remember, don't mix up, students, this, because graphite is solid, diamond also solid. All these are solid. All these are solid except oxygen here. So you can't have different physical state as allotrophic forms. Huh? No, not the chemical. The same element, Senuka, you can't combine that with the other element. Then there are so many forms. Oxygen combined with carbon, carbon dioxide, water, H2O, Oxygen combined with so many elements, even carbohydrate, protein, lipids. We don't call them allotrophic forms. Remember, different chemical formulas you can't take. When they combine with the other elements, we don't take them as allotrophic forms. And different physical state also we don't take as allotrophic forms. Okay, we have Senuka. So the same element in different forms in the nature without combining with anyone else. The same element combined with each other and arranged in different ways. So you take the same element, the different arrangement without mixing up with any other element. Now tell me, what is the gas present in the ozone layer? What is the chemical formula of ozone gas? O3. So oxygen, right? What are the two forms? O2 also made of only oxygen. O3 also made of only oxygen. Both are gases. So they can belong to the same physical state. Is that clear? Right. Now you can see even graphite diamond what? Graphite is made of only what? Carbon, no other element. Graphite is completely carbon. Diamond also what? Completely carbon. No other forms of, no other element present in diamond, only carbon. And the other one is the fourth example for this what? Phosphorus. So these are the 4 examples for the allotrophic forms of allotrophs. Oxygen, if you write here, oxygen is oxygen gas, and what is O3 here? O3 is ozone. If you don't write, ozone layer is made of ozone, O3. And phosphorus, there are 3 forms, allotrophic forms of phosphorus: red phosphorus, black phosphorus, and white phosphorus. So what are the 4 elements of the periodic table shown in allotrophy, students? CSOP, carbon, sulfur, oxygen, phosphorus. Out of these, the most important one is carbon. And then second, most frequently asked one, oxygen. Phosphorus, they don't ask much. Sulfur also, if you only can remember, but mainly carbon, oxygen, you should know. Then next one, shall I raise the screen? Then we are going to discuss 3 nonmetals in detail. 3 nonmetals we are going to discuss in detail. I will use the PowerPoint slides also to explain this. Okay. So you understood what is allotrophic forms, right? But same element without combining with any other element, the same element can exist in different forms in the nature. Those forms are called allotrophic forms. Those forms are called allotrophic forms. Right. Then next one. Right. Carbon. Carbon, what are the properties? What is the symbol? Capital C. So carbon exists as lattices. Can you write it, students? In front of lattices, you can write within bracket with a pencil at least graphite and diamond. That also we are going to discuss under 10th lesson. There are lattices, carbon form lattices. That also graphite and lattice structures, graphite and diamond. What is the hardest natural substance in the nature? Diamond. If you want to write, the hardest natural substance in the nature is diamond. Diamond is even harder than even a metal. To cut diamond, you can't use metals. Diamond cutting is a separate industry. The same element. Graphite, but graphite is not expensive. A pencil rod. Diamond is expensive. Even though both are made of same element, one is very expensive than the other one. Why? Because of the arrangement. Made of only carbon atom, but their properties are completely different. That is due to the arrangement of atoms in the structure. Due to the different arrangement of atoms, the structure. Then next one. Isotopes. Can you remember, students, in this lesson we have already done isotopes. What are the Isotopes of carbon. Carbon C612. Carbon C613. Carbon C614. I don't know how many of you can remember the definition of isotopes. Isotopes is what? Same atomic number, in other words, same element, but with different mass numbers. But with different mass numbers. Understood? So what is the atomic number? All these 6 carbon hands 666, but mass numbers are different. Allotropy already I have given allotrophic forms of carbon separately at the top. That's same as graphite and diamond. Then carbon present in the atmosphere as what? Carbon dioxide. Nearly 0.03% present in the atmosphere. Carbon that helps to regulate temperature of the earth. Remember, carbon dioxide is a greenhouse gas. CO2 is what gas? A greenhouse gas. And it can get dissolved slightly in water. And important for the what? Respiration of organisms. Next one, dissolved oxygen. Dissolved CO2, plants absorb dissolved CO2 for photosynthesis. And carbon is present in what? Biomolecules. What are the biomolecules? Carbohydrate, protein, these are called biomolecules. Biology, you had done our first lesson? Biomolecules. Any biomolecule, one common element is carbon. Then if you burn carbon dioxide and carbon is CO, students. Carbon monoxide, if you don't write, is a toxic gas. You should not stay inside, you should not go behind this lorry bus and all. Old diesel engines release more CO. That's why there's a vehicle emission test. Like, before you renew the vehicle license, you need to get a report whether you emit more emission or less emission from your silencer. So CO is carbon monoxide. Carbon monoxide. Right. Then before we uses of carbon, I have given what? To make pencil rod, what is used? Graphite. To make electrode also we use graphite. And as a solid lubricant, that also graphite. And diamond, now these are uses of graphite. All three, the first three are uses of graphite. Next one I have given what? To make jewelries and for cutting glasses. What is used? What is used? That is diamond. Cutting glasses and to make, you can underline now for cutting glasses and for making jewelries. Jewelries also use diamond. Plus, I don't know whether you have seen these water filters, they use carbon. Even Angur, they used to put to water in the past in Sri Lanka because they can absorb unwanted colors. They can decolorize water. So even black color, make black color ink and carbon fiber. So why we call it what? Ink. To manufacture ink, you need carbon. Pencil rod anyway carbon, graphite. To manufacture ink also you need, that's what we call carbon pen. Carbon is used to manufacture pen, carbon pen, ballpoint pen. Okay, water purification also we use, they use. Right. Then next one, okay. Before I move to nitrogen, students, I will show you some applications of carbon. You had done this in grade 9 science. I don't know how many of you have done nanotechnology. Nano carbon, that is actually, if you write here the uses of the carbon is one of the most widely used element in nanotechnology, nanoscience. Carbon nanotubes, single wall carbon nanotube, multi-wall carbon nanotubes, then fullerene, they all what? Carbon. Because carbon containing chemistry, like that branch is called chemistry of carbon containing compounds called organic chemistry. And can you remember at the beginning, the first lesson we discussed organic and inorganic ones. Organic means with carbon. Inorganic means without carbon. And I will show you the PowerPoint slides now. The uses or the applications of carbon different forms you can see here. Now these aliphatic forms of sulfur. Okay. Can you see the screen here? Allotropic forms of carbon. Can you copy down this? Students, can you please copy down this in your writing book? The other forms of allotropic forms of, because carbon, graphite, and diamond I give, but there are many other forms of carbon. Quickly copy down this. What is the meaning of crystalline and amorphous? Crystalline form has a regular structure. Crystalline form of carbon has regular structure. Nice arrangement. Atoms are orderly arranged. So why does this called crystalline form? Right here, carbon atoms are orderly arranged. Carbon atoms are orderly arranged. Regular pattern. I will copy down this now. Students, everyone should maintain a separate CR book for chemistry. Right? Chapter 3 chemistry in your CR books. I told only the tutor is not enough. You have to maintain a separate CR book for writing important notes. Carbon atoms are orderly arranged. When large number of carbon atoms orderly arranged. Orderly arranged. Okay. Here, no regular arrangement. No regular arrangement. No regular arrangement. No regular arrangement of carbon atoms. Okay, so the main difference between amorphous and the crystalline. Crystalline means carbon atoms are nicely organized, arranged, building a structure. So amorphous means random distribution, no regular arrangement of carbon atoms. So some of this you have, this is actually graphene. I will show you the pictures. Graphene is the thinnest material in the world. Hardest, thinnest material. Hardest, thinnest material is graphene. Graphene is just one layer of, one layer. But graphite has several layers of carbon atoms. This is just one layer. Only one layer of carbon. Only one layer. I don't know, they have and learn about the graphene in the, if you want to write search in the internet graphene, then we get, so only one layer. Graphite has several layers. Several layers. Layered structure graphene. Right. What is coal? Gallamuru. If you know, coal is a fuel, no? Fuel. Coal is used as a fuel. I'll give one example on each. This is used what? Carbon nanotubes. To make carbon nanotubes, they use graphene. This is also nanotechnology, nanotube, nanoball. Then coke, iron extraction, they use coke. And this is fuel. Lamp black, there's no much. But others like charcoal, anguru. After burning firewood or something, you get anguru, that is charcoal. Coal, charcoal, coke, lamp shoot. Lamp black means lamp shoot. That is lamp shoot. Okay. Done. Shall I erase this? Did you all finish copy down? Did you draw this, everyone? So see the same element. All this what? Only carbon. Diamond only carbon. The graphite is made of only carbon. Fullerene only carbon. But just because they are made of same thing, you can't expect the same properties because the way they have arranged in the structure different, would be different. That's the reason. Okay, so what is crystalline form? There's an orderly arrangement. Orderly arrangement of atoms. Here, no such order of the arrangement. Random distribution. Okay, I'll erase the screen. Anyone still copying and raise their hand? Done. Okay, then next one is students. Done. Okay, Anika, you're still copying down. Anyone else copying down? Raise the hand. Hurry up, students. Right, when you're done, please lower your hand, Anika. Anika, when you're done, please lower your hand. We are waiting for you. Right. But in case if you want to take, you can take a screenshot, or if you can even get the recording if you have missed anything during the online session, right? Okay. Now, let's see next one. So you can see here what? Appearance of them. But the most interesting thing is that we have a graphite. Do we have graphite in Sri Lanka? Yes. Yes. But we manufacture, we import sometimes pencil also from China. We have a huge graphite deposit. That is pencil rod. Understood? Black. Except diamond, the others are black. Except diamond, all the forms are black. Now here you can see amorphous for carbon, and you can see there's a nice array. Actually, there's a graphite has, if you want to take a screenshot, graphite has a layer structure. Here there are 3 layers. Exactly, there are 3 layers of this. 3 layers. Understood? There are 3 layers. That means graphite has a layer structure. That's why I told, if you take one of this layer, we call it what? Graphene. Can you see this one? If you take one layer, what is this called? Graphene. Can you see the connection? One layer alone, we call it graphene. This graphene, when you roll, we call it carbon nanotube. When you roll this, it becomes carbon nanotube. Same thing, they are outside each other. Understood? So carbon nanotubes are widely used in water filters. No, carbon nanotube also there are 2 types. These single wall carbon nanotube. Single wall carbon nanotube. Fullerene also like. Then next one. So then this is, you can see graphite and diamond. It's a big comparison. What is graphite and diamond comparison? Graphite is dull, not shiny like diamond. Graphite is opaque, diamond is transparent. Diamond is hard, graphite is soft. Graphite is common, but diamond is rare. So it's rare, hard. If you can take a screenshot, or you can write, diamond is the hardest natural substance in the nature. Hardest naturally existing material. Is that clear, students? Hardest natural substance. And one more thing, then is rare, not found everywhere. That's why it's expensive. Hardest natural substance in the nature. Plus rare, therefore the diamond is, you can write here what diamond is expensive. And graphite, obviously. Okay then. This is graphene. One layer. This is the structure of graphene. Here graphene. And several cell layers together called graphite. Understood now? And therefore diamond is what? Expensive. Rare, expensive. This is common, therefore not expensive. It's not expensive. Common. And next one. I have given the not. If you want, you can take a screenshot. This is how it looks. So you can see the between carbon upper layer and lower layer. There's a small dotted line here. That is the weak interaction or weak attractive forces. One layer is attracted to the bottom layer through small interaction. And this is in nanometer. You know the bond length. Can you see these atoms or the bonds? So nanometer with nano scale. What is the bond length? 0.1 nanometer carbon-carbon bond length. Actually, these dots represent carbon atom. All these dots represent carbon atom. So between upper layer and the bottom layer, what? 0.34 nanometer. Nanometer. So very small, not visible down here. Right. This is the structure of diamond. So there are covalent bonds. Bonds anyway we will be discussing later. Around each carbon atom there are 4 bonds. So can you remember I told electronic configuration of carbon is what? 2,4, right? 2,4. Therefore around carbon atom there are 4 bonds. Around each carbon atom there must be 4 bonds. If there are less than 4 bonds, then it is unstable and there will be free electrons and it will conduct electricity. Remember, graphite is the only nonmetal that conduct electricity. Graphite is the only nonmetal that conduct electricity. So wait, before we move to nitrogen, we will complete the tute, the next part. And right, students, so under graphite, we use them in electrodes. And right here, the only nonmetal that conduct electricity, that's why they are using electrodes. So battery is battery, right? The only nonmetal that conduct electricity. Only nonmetal that conduct electricity. The only nonmetal that conduct electricity is graphite. Now let's see next one, nitrogen. Actually, carbon is everywhere. Carbon is present in the atmosphere as CO2. Carbon is present in the earth crust as the graphite diamond. Carbon is artificially also reorganized as fullerene and carbon nanotubes. Carbon is available in our body. Carbon, carbohydrate, protein, lipids, nucleic acid. Carbon is present in our body. That means carbon containing compounds are called organic compounds. Carbon is a non-metal, but it conducts electricity. Carbon is a non-metal, but not all the forms, only graphite conduct electricity. And carbon containing compounds are called organic compounds mostly. And chemistry of carbon called organic chemistry. So carbon is very important. That is the first element of the group 4. And carbon is present in fuel, example coal, gallangru. Carbon is present in hydrocarbons like petrol, diesel. All the fuels contain carbon as hydrocarbon. So it's carbon is where carbon can form 4 bonds, valency 4, group 4, atomic number 6. So those things you should know, right? If you can write an essay about carbon, that would be far better, because by combining all this, all what you know about carbon, you can write in a story. Right. Then next one, nitrogen, second element. Nitrogen also non-metal students. Actually, nitrogen, it exists as nitrogen, 78% in the atmosphere. That is the most abundant gas in the atmosphere, 78% in the atmosphere, but not as N2, as N2 gas, nitrogen gas. And the other most important, you can write if for nitrogen, between nitrogen and there's a triple bond. There's a triple bond. Therefore, triple bond is stronger than double bond. And double bond is stronger than single bond. When there are multiple bonds, they become stronger. So between nitrogen atoms, there's a triple bond. Therefore, it's less reactive. Even now when you breathe, what 70%, 78% nitrogen go into your lungs, but it's not dissolved in blood. It's again returned when you exhale a certain amount. And nitrogen is what? Even though there's 78% nitrogen in the atmosphere, do we see any colored area in the atmosphere? No, because it's colorless. That is better. Otherwise, what happened? We can't see anything because of because 78% nitrogen in the atmosphere. The other one is odorless, and it's insoluble in water and very less reactive or almost inert. And its reactivity is very low, less reactive or inert. Therefore, nitrogen gas, where do we use them? What are the applications or the instances of using N2 gas in our daily life? You can see the right-hand side, I have given applications. Nitrogen we use to fill vehicle tires, tubeless tires of vehicle, we use nitrogen. Have you seen sometimes petrol shed, they put what? Nitrogen is available. Because when you pump nitrogen into the tire, you don't need to refill air again. Nitrogen light in weight, normal air content moisture and is heavier, and the pressure maintained for a longer period. Otherwise, if you pump normal air, after every week you have to check the tire pressure. But once you pump nitrogen, you don't need to check the tire pressure nearly 2 months, up to about 2 months maximum. Then to manufacture ammonia, what is NH3, students? If you don't know, right, what is NH3? Ammonia. To manufacture ammonia, AMMO, this is nitric acid. To manufacture nitric acid and ammonia, we use what? Nitrogen gas. Nitric acid, we call it Guinea water. It is illegal to keep your nitric acid. It is used to make explosives. Ammonia is widely used in rubber industry, and ammonia is also used in these disinfectants. To fill electric bulbs, so the filament bulb, electric bulb in the sense filament bulb. Filament bulb, empty space is what? Filled with this gas, nitrogen gas. Because it's less reactive. Otherwise, if you pump normal air at high temperature, filament get burned. Filament get burned, then you have to replace the bulb. Next one, to prevent oxidation of food. That means what? Food packaging. Because if oxygen is present in the food packaging or the packet or the can container where the food is stored, it gets oxidized, quality drops. But when you fill nitrogen gas to the empty space of the milk powder packet or peanut packet or whatever, sometimes they put a silica gel packet to minimize moisture. Do not eat packet. Silica gel, that is to absorb moisture inside those. Because otherwise, if there's moisture, microorganisms can easily grow. There's a silica gel packet. Plus, nitrogen gas used as a coolant. It's very cold. Liquid nitrogen. We call it liquid nitrogen. Liquid nitrogen has in temperature minus 186, as I remember. Therefore, liquid nitrogen also used in food industry to quick freezing of food. You can quickly freeze, because when you use normal ice melt and the things can get wet. I mean, it can damage the material. But when you use liquid nitrogen, what? It does not wet. It does not make the object moist. So I will show the PowerPoint slide under nitrogen. Now you will understand here nitrogen. The screen. If you want, you can copy down anything else you want here. Nitrogen gas. Get here. 78% by volume in the atmosphere. Colorless, odorless, tasteless, non-toxic. It's non-toxic. Otherwise, we are in trouble, because every time we inhale nitrogen also, but it's not, even though it's not dissolved in blood, it's non-flammable. It's not a combustible gas, or it's not a fuel. Will not support life. Gas slightly lighter than air. Right? Less denser than air. So this is some common properties of nitrogen. Then next one. Can you see, this is the filament? Can you see here, students? Filament of the bulb made over. This is the filament is made of the metal. This filament is made of metal. Tungsten metal. Filament is made of tungsten. Tungsten is a metal, W. And this one is copper. Connecting wire, side wires, copper. And the empty space of this bulb filled with what gas? Remember, I told one use of nitrogen is what? To fill electric bulbs. So this is filled with what? Nitrogen. You can see what? Nearly 85% nitrogen. And the rest is what? Noble gas like argon, no helium. Okay, done? Then tungsten filament, it's become red hot. I think you have seen now these lamps we don't use much. Why? Problem is they emit more heat than light. It's become very hot. You can't touch the bulb after a few minutes. So lifetime is about 1,000 hours, because if you use LED, what happened? LED you can use 50,000 hours. That means that when you use one LED, for that time you have to use about 50 filament bulbs. So this tungsten filament can get burned. Even if you have oxygen inside, then also it gets oxidized or burned. That's why inert atmosphere. Some vehicle headlights, the xenon lamps. When you change the gas inside the bulb, the color will change. Understood? When you change, because the gas inside the bulb, you get the color. So basically, you don't need to memorize all this extra knowledge, but I want you to remember what? Nitrogen gas is used to fill electric bulbs. Okay. The next one, I told nitrogen gas is used to fill what? Tires. Tires are filled with N2 gas. For filling tires, there's also use of nitrogen. Nitrogen actually light in weight. So the fuel economy also improved. You can run more kilometers, at least 1 or 2 extra kilometers. If you replace your tires with nitrogen, it's light in weight. Heavier one, when the gas becomes heavier filled into the tires, engine has to make more effort. Then the fuel consumption increase. Okay. The next one. Yeah, that's benefits of nitrogen. What are the benefits of pumping nitrogen gas into a tire rather than pumping normal air? You have to pay a bit extra, but it's worth filling, because otherwise you're wasting more time. Regularly, you have to check the tire pressure after every 3 or 4 days. But when you pump nitrogen, you don't need to check at minute. 1 month for sure, your tire pressure will not drop. Improved vehicle handling, increased fuel efficiency, better pressure retention, less regular wear, and extended tire life. Right. That's nitrogen, N2. Not N now. Nitrogen gas is N2. The next one, can you remember I told you empty space, this groundnut, have you seen the real appearance of these groundnuts? Right? Now, this is empty space of this filled with what? Nitrogen gas. Why? Otherwise, the freshness, you will lose the freshness of these food items. If you pump normal air contain moisture. Normal air contain moisture. And it can get wet or quality drops, the freshness. Peanuts, no, yeah, peanut packets. Then this nitrogen gas, potato chips, food items, food space filled with this. You don't get the the same freshness if you pump normal air. What happens if you put these biscuits into a potato chips into a normal box and close the lid? You have a plastic box in your house and close the lid after pulling this. What happened? Next day, you will not get the same freshness. You will not get the same quality. Understood? But is that when you open the packet, nitrogen goes to the atmosphere? It's not a problem. It's not toxic. Colorless, odorless, tasteless. Therefore, it's no harm using them in food packaging. But the thing is, due to additional cost. So nitrogen also used in the production of fertilizers. Nitrogen is one of the main. You had done the first lesson minerals. What are the minerals? Nitrogen, phosphorus, potassium. So urea. Urea contains nitrogen. Because without nitrogen, the plant will not grow properly. Nitrogen is an essential mineral to the plant. Mineral. Therefore, nitrogen is used to manufacture fertilizers also. With fertilizers. Fertilizer is the industry. I told you this canned food, empty space is filled with nitrogen. Ice cream, that is liquid nitrogen. So this is an application of what nitrogen? Liquid nitrogen. Some of you will have fan of you any students I think like ice cream, but so this is they get liquid nitrogen issues. Okay, liquid nitrogen. Quick freezing of food. Not normal nitrogen gas. Liquid nitrogen is very cold, minus. Again, the same thing. Next one is liquid nitrogen. Application of liquid nitrogen. Sulfur, I told. So that's about nitrogen. Then before I move to sulfur, let's see the table again about sulfur. So I explained to the PowerPoint slide also the applications of nitrogen and liquid nitrogen. Sulfur is a yellow, highlight the word, student, those who have got the printout, yellow brittle solid. Yellow and is brittle. Because non-metals are brittle anyway. Non-metals are not malleable. Sulfur is a non-metal, okay. So these are non-metals. And this is very important, students. Please highlight. Very, very popular question in papers. Burns with blue flame and emit SO2. So if you write the reaction, that is white smoke. When you burn sulfur products, it reacts with oxygen and produce what gas? Sulfur dioxide gas, which can lead to acid rain as well as not good to inhale. Therefore, you should not burn sulfur in your school lab other than for the teachers observe, other than teachers demonstration. Then occurs as and shows allotropic forms. I told you that sulfur exists as S8 molecules, 8 sulfur atoms combine and become like a crown-shaped structure. So that is how they exist naturally, and they are insoluble but soluble in organic solvent. Right. Then what are the advantages? You know, with sulfuric acid. What is sulfuric acid? Battery acid. Sulfuric acid means what? Any battery contain battery. So car battery, motorcycle battery, sulfuric acid. We can write here battery acid. Battery acid. What is battery acid? Now to make gunpowder. I will tell a nice story. You have this box of matches, the guinea petti. Sulfur is used to make is used to make gunpowder, crackers, matches, guinea guru. And vulcanized rubber to make rubber a valuable product for value addition. Again, they use sulfur. And fungicide soap, they have aluham or something. Fungicide soap also contains sulfur because the fungus cannot grow in the presence of sulfur. And to make solvent, carbon disulfide. So they don't ask all these uses in the exam. 1 or 2. So there are so many non-metals there, but you have to remember only these 3: carbon, nitrogen, sulfur. Only these 3 non-metals. Other non-metals no need. Other non-metals only the symbol and the atomic number if it is within your first 20 elements. But these 3 non-metals, you should know the properties and uses. They will never ask to write down the properties, but they can ask which of the following is incorrect about sulfur. They can give MC. Or structure, they say write down 1 use of sulfur. Write down the elements shown in allotropy. They can ask MCQs. Okay, now I will show you the sulfur, the PowerPoint, and if any one of you want, you can copy anything you want. This one I showed you earlier also on allotrophic forms. Sulfur, actually there are 2 forms, crystalline. If you can copy down these students. If any one of you are planning to do A-level science subjects, then it will be more useful, very useful. So you can you quickly copy down this in your additional knowledge in your writing book. Hurry up. Quickly copy down. Amorphous means what? There's a regular crystalline form has a regular structure, regular arrangement, or orderly arrangement. Regular or orderly arrangement of atoms. No such order of sulfur atoms, right? Raise the hand, those who are still copy down. Hurry up. Otherwise, I'll erase this. Please raise the hand, those who are still copy down until you finish copying down. Keep your hand raised. When you're done only, lower your hand. Lower your hand when you're done only. Until then, you have to keep your hand raised because otherwise, I don't know they are done or not. Everyone else done because none of the others raising the hand. All this have you all done? Only Anika and Narayan Maya raised the hand. Okay, when you're done only, you can lower your hand. You can copy down this in. I told you, you have to maintain a separate CR book for chemistry, additional notes. Okay, right. Now, next one. So if anything else you want, you can copy down. Insecticides or fungicides. So it is used in sulfur drugs also. Sulfur is used. Sulfur is a brittle solid. It's a non-metal. It doesn't conduct electricity. Sulfur is insoluble in water. It's insoluble in water. It's a non-metal. It doesn't conduct electricity. Rubber industry, they use sulfur. Why? Increase the strength or the hardness of these rubber products. We have rubber in Sri Lanka, yes. We export rubber. They have rubber trees, rubber plantations. rubber factories. But sometimes we import even rubber eraser from China. We have graphite deposit, but we import sometimes pencil also from the other countries. And remember this sulfuric acid, that's called battery acid. We need sulfur to manufacture sulfuric acid or battery acid. Vehicle batteries are battery acid, sulfuric. What is the chemical formula? H2SO4. If you want, you can copy down anything else in your writing book. I have given these things in your tutor also. The next one is the crystalline forms of sulfur. Not gems, right? Is the real appearance of sulfur. Sometimes what happens, students, some schools, they have practical exam, or like assignments. School, they display chemicals, sometimes chemistry quizzes, or sometimes even a spot test. They have chemistry spot test. They display them without labeling in the laboratory, and then the students, they have to identify and identify them, those chemicals. And if you have not seen them, therefore, when you start this lesson in the school, you better ask from the teacher, can we see sulfur from here? Can we go to the lab and see sulfur? Real appearance is a non-metal. What is the atomic number of sulfur? Raise the hand, those who can remember the atomic number of sulfur and the configuration of sulfur. Hurry up. Raise the hand. Reply on chat. Hurry up. Without looking at the notes. Let's see how many of you can reply atomic number and the configuration of sulfur. I'll give 1 minute. Reply on chat. Hurry up. Let's see how many of you, because we have done the configuration at the beginning of this lesson. Otherwise, you are in trouble in the exam. Only 3 students replied. What about the others? Atomic number and the electronic configuration of sulfur. Okay, very good. Only Onara, then Harini, Gitmi, Rihab, and Sanuka only replied. Gitmi not 288, okay? 286. Gitmi, your atomic number is correct, but configuration 286. What are the possible valencies for sulfur? Valency also you have done, right? The chemical formula. Can you quickly reply on chat? Let's see. How many of you can remember the valencies of sulfur? Sulfur valency. I'll go a small hint. There are 2 possible valencies, lowest and the highest valency. What are the 2 possible values for the valency? That means number of bonds that can be formed by sulfur. So the combining power of sulfur, valency. Most common valency is 2. Maximum valency 6. Okay, very good, Onara, Rihab, Harini. Yeah, now you can remember the things up to date. When you immediately reply, I know that you can remember the things up to date. The students, you have to don't wait until the exam is close to study science. Okay, because grade 10 and 11, 35 lessons for the O level. So you can't remember. I mean, you can't. If you don't study up to date, if you don't regularly, if you're not studying, what happened? Not like the other grades until few days before the exam you don't study. So then the few days before the exam you study everything and get 60, 17 marks. That is not possible for grade 10 and 11. Because it's a bit hard. It's not just science, chemistry, physics, and biology, plus content is more like deep learning. So you have to study and practice questions before the exam. That's why we are doing the paper class also separately. Now students keep Sunday early, this Saturday early morning time 6 to 8 time free. Sometimes I'll make the class 6 to 8. After this May oral batch. After this time oral batch, I'll make the class be early because some students they find it difficult because they have the other classes sometimes physical classes after 8 in the morning. Then sometimes I might make it 6 to 8 in the morning the same day. Now we are starting 8:30, so I can make it 6 to 8. Then it's easy for you. Then you can save the rest of the time of the day for the other works. Now my third question. How many of you can reply on chat 3 chemical formulas or 3 compounds containing sulfur? Chemical formula, correct chemical formula of 3 compounds with sulfur. Quickly reply. You can put commas and reply. 3 chemical formulas containing the element sulfur. Correct formula, not the incorrect one. Let's see. 3 chemical substances containing sulfur. I need the formula. Correct formula. Okay, Sanuka gave 1. Very good, Sanuka. What about the others? I'm waiting for your answer, students. Some students they don't respond. That means they are not studying. Because we have done chemical formulas now. We have done valency. We have finished all this. We have done electronic configuration. Okay, very good, Sanuga. You replied 3 correct formulas. What about the others? I'm waiting. Okay, you can take time and do it. Okay, I'll give 2 minutes more. Three chemical substances containing sulfur. Okay, I got Onara. Okay, very good. And not the iron, Rehab. Not the iron. I need the correct formula. Not the iron. Not the sulfate. I need the complete formula. Not the charge ions. Rehab. And yeah. And okay, Pevin, you gave H2S hydrogen sulfide. Onara gave potassium bisulfate. Very good. Sanuka gave all 3 correctly. Copper sulfate, H2SO4 and sulfur dioxide. Okay, I'll write the others. Can you copy down in your writing book? Chemical compounds containing sulfur. Only 3 students gave correctly. Look at the screen, everyone. One example, sulfur dioxide. Sulfur dioxide. Sulfur dioxide is a gas. sulfur dioxide is a gas. Then H2S, hydrogen sulfide, is a gas. Why 2 here? Because sulfur valency 2. Hydrogen sulfide, that's also gas. That both these are poisonous gases, are toxic gases. Because I just wanted whether you can remember the previous part. Hydrogen sulfide. Actually, it has the smell of it's foul odor, the smell of rotten fish. Hydrogen sulfide, not ide, sulfide. That also gas. Then next one, I got from Sanuka H2SO4. Right? H2SO4, very good. Sulfuric acid, that's a liquid. Remember the others, quickly copy down. Sulfur can exist in different forms. I mean, as in different compounds. Sulfuric acid. Sulfuric acid, that's a liquid. Then carbon disulfide, CS2, liquid. Are you all copying down in your writing book? Carbon disulfide. Carbon disulfide. That is liquid. The next one. Yeah, okay, Onara, okay, ammonium sulfate, copper sulfate, right. Then you can write calcium sulfate, solid. Calcium sulfate. Calcium sulfate, solid. Copper sulfate. Other students also see you might have heard this, but none of you the others didn't reply about this. Now students, sulfur and sulfur, there are two now. Yeah, British we use sulfur SUL PHUR. I think your book also, but the new method of writing this sulfur, this is the most internationally accepted SUL FUR. A-level chemistry we use this one SUL FUR, sulfur. This is the most correct form, but for O-level both this accepted. Therefore, some of this I might have given SUL FUR. Don't worry about that. Either PHUR or FUR, no problem. Copper sulfate, that is a solid. Why can't you remember this hydrated copper sulfate? In the presence of water, this turns blue, copper sulfate. With water, it becomes blue crystals. Therefore, copper sulfate is very important, students. So it can be used to identify water in the laboratory. No? Copper sulfate can be used to identify water in the lab. In the copper sulfate, without water is white, with water it turns blue. So it's a colored compound. Colored compound. So I got Onara gave ammonium bisulfate. That also correct. Ammonium bisulfate, potassium bisulfate, correct. Sodium bisulfate, NaHSO4. Ammonium sulfate, NH4 twice SO4. This also accepted. Sodium bisulfate and ammonium sulfate. So these are, you can see sulfur containing compounds, some of them gases, some of them liquid, some of them solid. So not pure sulfur. If you burn sulfur, it becomes sulfur dioxide. Burns with blue flame. Okay, shall I erase the screen? Anyone still copy now and raise the hand? Okay, then next one. I'll erase the screen. You can see this is very interesting. Sulfur is used in many things. Most important is the manufacturing of sulfur compound in sulfur dioxide. Medical drugs. Can you see what is the first diagram here? Matchstick. This head of the matchstick contain what? Sulfur. Sulfur. Even dye, the second diagram, it represents dyes here, dyes. This contains sulfur. So this is what we use. So you can see the matchstick. You have sulfur compounds. Head of the matchstick. Sulfur present. And there are some other chemicals also. If you want, you can take a screenshot if you are interested. Have you ever thought about this chemistry of this how it works, or you need to rub the box of matches? So it has matchbox. This contain red phosphorus here, red phosphorus, black phosphorus, and white phosphorus. Can you all remember? We discussed red phosphorus, allotrophic forms of phosphorus that's used for ignition. Powdered glass, so friction. So that is when you rub the matchstick against the box, what happened? It's get catch fire, it ignites. So nowadays, most of the matchbox they use red phosphorus because white phosphorus more reactive, like it can easily ignite, causing fire very quickly and dangerous for workers and users. It's interesting, right? See the way applications. Okay, shall I raise? No, they don't ask this for the exam. The applications of sulfur. But in the friction lesson also, you need this. I don't know if they have learned before friction. Imagine due to friction, wildfires, Lavogini. Ancient time, they found the fire also rubbing the stones against each other. Stone Age, they found fire. That is friction. Even engine, the noise you get due to friction. When two surfaces are rubbing each other, you get a noise. Even when you on the gas cooker, you get a tick sound when you on the gas cooker. This one you move against each other, then it get heated up and ignites or get catch fire. Okay. See, fungicide. Sometimes fungus can damage those crops or the vegetables or the plants. Then you can use this sulfur content. Even aluham, we use fungicide soap. The applications. In tires. Right. And the last one is metalloids, students. So today we can finish the lesson. Metalloids. So can you see the metalloids, the position in the periodic table? They have put an arrow. Metalloids. Actually, what are metalloids? Having properties of both metals and non-metals. I'll highlight here. Metalloids having what? Properties of both metals and non-metals. So this is like a staircase here. I'll draw a line here. See here. You can see boron, silicon, germanium, arsenic, antimony. All these are like, these metalloids here. This side metals, all these are metals, this side non-metals, but in between the boundary of metals and non-metals, you get metalloids. So anyway, in the periodic table, we can classify elements into three groups: metals, non-metals, and metalloids. Metalloids having the properties of both metals and non-metals. So there are only very few, like group 3 boron. No need to memorize all this for your syllabus. Your periodic table only boron and silicon. Only boron and silicon non-metals in your periodic table. Not group this is group 3 and group 4. Boron group 3 and this is group 4. Boron under group 3 and carbon under group 4. Then next one. This is the ladder. So these are actually A level. Sorry, when you come to grade 11, you need to remember the others also because you get electronics and all. Therefore, can you copy down these 5 in your writing book? Write 5 metalloids in your syllabus. Grade 10 only 2, but when you come to grade 11, you need the others also. These 5 can you copy down? Symbol and the name both. Okay, symbol and the name both. Boron, then silicon, germanium, then arsenic and antimony. These are the 5 metalloids in your syllabus. So boron come under which group? Group 3. Why boron is a metalloid? It shows both metallic and non-metallic properties. Group 4, there are 2 metalloids. Group 5, there are 2 metalloids. Tellurium and polonium not required for your O level. Quickly copy down. No need to draw this. Just copy down 1 to 5, the symbols and the name of the 5 metalloids in the syllabus. Even in the syllabus. Remember, students, when you're writing the symbol, the first letter has to be capital. Okay. First letter has to be capital and the second letter simple. When there are 2 letters for any symbol, first letter has to be capital and the second letter should be in simple. Right, students, shall I erase this now? Right. I'll erase the screen. Atomic number no need. So this is the appearance of those metalloids. Appearance, physical appearance of the metalloids, but you have to remember only up to antimony. But they will not give this no need to memorize the appearance, but they're very hard. No, they have high melting point. They have high boiling point. They are hard and strong. Out of these 5 metalloids, what do you think is the most important, most widely used metalloid? Can you guess? Can you reply on chat? Out of these metalloids, what is the most widely used metalloid? And that is the second most abundant element in the earth crust. That is the second highest element in the earth crust. There's one metalloid, second highest element in the earth crust, and that is widely used in very valuable. Why? Why and pegging? Yeah, give me, sir, can we take potassium bisulfate? Yes, correct. take. KHSF, I know only I saw your message. Sanuka, okay, very good. Silicon, yes. Onara, correct. Sanuka, yeah. Silicon, why I'm telling? Silicon is used to make solar cells, solar panels. Can you write, students? Silicon is the second most abundant element in the earth crust, and silicon is available in the earth crust as silicon dioxide. Second most abundant element in the earth crust. Then what is the most abundant one? If silicon is the second most abundant, what is the most abundant one? In the earth crust. Oxygen. Most abundant element is oxygen. That if you want to comment on that also. Most abundant metal element in the earth crust is most abundant element in the earth crust. Most abundant element in the earth crust is oxygen. Oxygen. Okay, done. Most abundant element in the earth crust is oxygen. Second most abundant element is silicon. So what are the how does silicon exist in the earth crust? How does silicon exist in the earth crust? Because no point of just memorizing only the symbol of the metalloid. You should know where does this exist in the earth crust and how it exists. Silicon not available in pure form, student. It is available as silicon dioxide. It's called silica, sand, silica, or silicon dioxide. SiO2, silicon dioxide. What is the first one? Is carbon dioxide. Above silicon, you have carbon. Carbon become carbon dioxide. Carbon dioxide is a gas. You know, group 4, the first element carbon dioxide is a gas. But silicon dioxide is a solid. Silica, sand. And silicon is extracted. Pure silicon is extracted from what? Silicon dioxide. That extracted silicon is used to make what? Solar cells, electronic items, solar panels. So therefore, now you can understand, to make solar panel, solar cells, electronic accessories, we need the element silicon. So if you take your mobile phone, you have silicon in it. Not only that, if you only can take silicon tube, like if you take hardware shops and ask silicon tube, like bathroom fittings and all, they use this. It's like a glue, gum, silicon. And even silicon used in cosmetics to get glowing appearance of the lipstick and all, cutex, silicon used in cosmetics. So silicon is a very useful element after carbon. Therefore, in the exam, mostly they ask questions out of these 5, I told 5 metalloids, boron, silicon, germanium, arsenic, and out of these 5 metalloids, mostly in the exam, they ask questions related to boron and silicon. Out of that also, mostly silicon compounds. Okay. I'll erase the screen. You copied on, right? Don't just wait, because you will forget it after 2 years. Or sometimes you need this for A-level also, these things will be useful. Now I will ask one more question. What is the most abundant element in your body? In human body? What is the most abundant element? That this in the earth crust most abundant element, oxygen. In the human body, what is the most abundant element? Highest percentage by mass. I'm asking not the compound, Sanuka. I'm not asking the compound, I'm asking the element. If it is the compound, okay, water, but element. Even water contain oxygen. Answer is oxygen, not carbon. The first lesson, students, you have the first page, your grade 10 textbook. I think most of you are starting the grade 10 first term this 27th of March. 27th, end of this month, you are starting the government school, they are starting the first term grade 10. So we have now almost done 3 lessons, no? When you start the school, the first lesson, we have done 3 lessons. So in CC, we can do like this because that's why I have enough time to explain these things in detail. Otherwise, no point of just like transferring the content, the same content, no point of copying down again in your writing book. That's what most of the teachers are doing. They repeat the same content in your writing book. It's like they teach the content, not science of the textbook. Right. Okay. You can note down these things also. The next one. Right. Then next one. So this is what I explained. See, silicon compounds. How many of you are planning to do IT for grade 10 and 11 IT? How many of you are planning to do IT? You have selected IT for grade 10, 11 IT. You are doing all level IT, selected basket subject IT. So it's a good option, right? Because in the future it will be useful, right? Because even A level you can do IT. If you want, if you like, you can do IT, Maths and Physics for your A level. You can select that stream. Instead of engineering, you can drop chemistry and select IT. Okay, very good. So you can see the semiconductors. This is called diode. This is called diode. What is this? LED. LED. This is called transistors. Because anyway, you need this for grade 11 science. You need this again in grade 11 science. Diode, LED, transistors. And this is called ICs, operational amplifiers, integrated circuit, IC. What is IC? Integrated circuit. These are solar cells. So, yeah, silicon is required. But you can't dig the earth and get pure silicon. You can't just dig the earth and get pure silicon. Well, these are electronics. Remember, students, without silicon, no electronics in the world. No electronics, no electronic devices. Your mobile phone, electronics. Television, electronics. Radio, electronics. Calculators, electronics. Your router, laptop, all the devices that you are using right now, it's just because of electronics. Electronics come under which subject? Physics. Electronics come under which subject? Physics. Right? Therefore, but we call it computer science and in IT, but there's no IT in the world, no computer science in the world without physics, because computer is manufactured using the knowledge of physics. So handled by this, so maybe you are doing the graphic design or whatever software engineering, but to do software engineering, you need a computer. To do graphic design, to do computing, you need a computer. This computer comes from physics, electronics. Remember that. Sometimes musical instruments played by artists, but box guitar, electric organ, piano manufactured by scientists. It's a branch of physics, musical instruments. You have that lesson in next year, grade 11. Musical instruments. Musical instruments are in the music room, but to manufacture, you need the knowledge of physics. Played by artists. Remember that. Artists, they use paints, dyes, pigments, but chemistry is used to manufacture them. You need chemistry to manufacture dye, chemicals. All these are chemicals, colors, dyes, paints, chemical industries. That's why every year there's a Nobel Prize for what? Chemistry, biology, and physics. Chemistry, biology, physics, medicine, there's a Nobel Prize. even without chemistry, you will not have any clothes. You have to hide behind a tree without clothes, without chemistry. Without chemistry, you have to hide behind a tree because you will not get any clothes. Clothes, fabric, chemical industries. Remember that. This is, I told that silicon tube. Please raise the hand those who have seen this. Bathroom fittings, this bathroom fittings, they apply this fixed two glasses, they need silicon. How many of you have seen this? You need silicon. Silicon compounds are used here. Silicon tube. Even water fittings, the bathroom fittings also they use this. Even windows and all. Yeah, some of you have seen, right? Yeah, okay. Nara Sanukarai. Silicon compounds are used. And you see this, they have got the name of this silicon. Remember, this is waterproof. Waterproof. Waterproof sealant. Only two students have seen this. Others, you have never heard about this. Right. So in aquarium, you know, in sometimes in construction industry, tile and all, like they use this. Chemicals. Sometimes gutters, Vahipili and all, when there's a leakage of water, they use this. Gutters and plumbing, bathrooms, when there's a leakage of water, not like the slab or concrete, I mean, small place, so you can use this sealant. I have given many uses of silicon. You can copy down if you want. Ceramics and bricks, semiconductors, computer chips, solar cells, Portland cement, fire bricks, silicon is used. There are many other applications. They have given few. Okay, done. Did you finish copying down? No need to copy down everything. Don't copy down sentences, students. Uses of silicon, you can just put commas and write, but ceramics, bricks, solar cells, computer chips, and like that, you can put underline words only you can use. Underline words only you can copy down if you want. I have given that in your, I think in your textbook also you have, and your tutor also I have given. So if there's a use of silicon, at least one of these you have to remember, right? Not everything. The next one. Is the appearance of boron, I think. Boron. So this is how it looks. Boron. This is how the boron look. Boron, capital B. Boron. Boron B. Boron also what? It's not a metal or non-metal. It's a metalloid. Shows both metallic and non-metallic properties. The next one. Shiny black here. There, can you see the previous image? Shiny black metalloid. It's a solid. It shows both properties of metal and non-metal. It shows both properties of metals and non-metals. It's a poor conductor at low temperature. Poor conductor. It's not a very good conductor, but conductor increases with the increase of temperature. I told you had to remember only boron and silicon, right? Only boron and what are the two metalloids in your syllabus? Only boron and silicon. Grade 10 syllabus. Huh? When you come to grade 11, you need arsenic, antimony, and germanium also. Only B and C. Yes, silicon. So you can take a screenshot. So you can copy down all the keywords. Don't write sentences. Shiny black solid. Shiny black solid. Shows both properties of metals and nonmetals. Shows properties of both metals and nonmetals. And it's a poor conductor at low temperature because it's a semiconductor. It's a semiconductor. When you go to a school laboratory, you can see some glasswares, they have named borosilicate glasses. Look at the screen, students. What is borosilicate? Both boron and silicon is used to make these glasses. That means glasses contain two elements. What? Silicon and boron. Normal glasses contain silicon. Remember, students, silicon is also used to make glasses. Silicon and boron. Because they can withstand high temperature. Normal glass, you can't heat, but boiling tube, what is it called? Boiling tube. Boiling tube can withstand high temperature. What is boiling? Boiling tube. Boiling tube. But you can't, test tube sometimes cannot tolerate that much of high temperature. So can you see here? They have given here borosilicate glass is what? Borosilicate glass is what? Very resistant to thermal shock. And it doesn't expand much because any item, there's an expansion on heating. So a German glass maker, 19th century, Pyrex, that is the other brand. It now borosilicate was replaced using the word Pyrex in the UK or European society. Therefore, the glasswares that you use in laboratory are different from the normal glasses that you use at home. Wine glass and all this, because these are used for heating and mixing chemicals. Therefore, they should be less reactive and should be resistant to heat, like Okay. So borosilicate, what glass? Borosilicate glass. Boron and silicon used in glass industry. Can you write? Can you put a stand right in your writing book? Write, student, hurry up. Write both boron and silicon used in glass industry. Silicon boron oxide is used in glass for manufacturing glasses. Example, right? Borosilicate glass. Example, right? Borosilicate glass. Borosilicate glass. Then that's all this one. We'll quickly complete the tute now. About that's what you have to remember about metalloids. I have given the last page about boron. Now there are 5 metalloids. You better write the symbol here. Boron, silicon, germanium Ge. Complete the blanks. Look at the screen. Arsenic As, antimony Sb. The symbol. Actually, this is from group 3. Silicon and germanium actually come from group 4. Antimony and arsenic and antimony come from group 5. No. Group 4, no? Carbon, silicon, germanium. Yeah, this is group 5. Nitrogen, arsenic and antimony group 5. Yeah. So I have given uses separately here. Used to make solar cells, transistors, diodes, computer equipment, silicon. Other than that, you can write to make glasses, so you can write if you want. Solar cells be important. And there are 2 forms of silicon, crystalline forms and the amorphous form. And boron you can write to make this stuff. You can write here even glass industry also they use. These are some of the properties here. These properties are common to silicon also. High melting point, high density. If you want to write, silicon occurs in the nature as what? SiO2. So basically metalloids what? Metalloids shows what? Show both properties of both. Show properties of both metals and non-metals. Show the properties of metalloids. Show the properties of both metals and non-metals. Metals and non-metals. Okay. Metalloids, they show the properties of both metals and non-metals. Okay. That's the end of this lesson, students. But you will not get big questions like a lot of questions from metalloids. Metalloids, you don't need to pay much, and that's why I didn't give a big note for metalloids here. But non-metals, they can ask, especially nitrogen, carbon, and sulfur. Mostly you get the first part. The most important part of this lesson is the first part. But the rest is like content-based learning. It's like facts and abstract learning. So the remaining questions, so I have given, you have the remaining pages, we have questions. Remaining pages, we have questions. So I want you to try them at home. I'll discuss them in paper class, Sunday 12:30. Sunday 12:30 paper class. Okay. Sunday more 12:30 p.m. paper class. I'll discuss them. So I think students, you should better join the paper class or at least get the recording and complete the answers, because otherwise it will be a problem, because theory only not enough. So you need to practice questions, textbook exercise, and these questions I'll be discussing in the paper class. So now we are doing the second lesson revision. Second lesson revision. Okay. Done. Shall I wind up now? So almost 10:30. So then we have to start the new lesson next week. Next week we are starting new lesson. That is unit 4 physics. Next lesson we are discussing. Next week we are discussing unit 4 physics. That is Newton's laws of motion. This one. I don't know how many of you got the textbook now. We are going to start this lesson next week. Fourth lesson, Newton's laws. This one. Newton's laws of motion is the fourth lesson, right? That's physics. That is a very short lesson. It won't take much time. Fourth and the fifth lesson, not lengthy. Now, up to which lesson you have to do for your term test? Up to chapter 6. Up to chapter 6, you have to finish for the first term test. So anyway, we can even complete.